Okay. Is it recording? Okay. Okay, so that rho, sorry, saya start balik. So rho minus rho naught is your delta rho over rho naught. So this rho goes over here. So I am left with, I need space. I'm left with rho naught alpha delta t rho minus rho naught. So when I move this rho naught to the other side, I will get rho naught plus rho naught delta alpha t. So I factor that out to become, sorry, rho naught 1 plus alpha delta t, which is the same way we derived our equation in chapter 14. So this is like the same thing. Okay, so delta rho over rho naught equals to alpha delta t, or this is your equation, just expand it. And then delta r over r naught equals to alpha delta t. Okay, what does delta t mean? It means final temperature minus initial temperature. Sama je. Delta always means this, final minus initial, or current minus initial or original. So this is the same case. So this guy means T current or T final minus T initial or T naught. Sama. Okay. So resistivity is rho, R is resistance. So that's different. So you have to differentiate between the two. So resistivity is dependent on, we know this equation, R equals to, resistance is dependent on resistivity and is proportional to length over A. This guy is a constant, but with temperature, it can increase in value. Tapi selalunya kita akan bagi value resistivity at 27 degrees Celsius. Tak apa, kita akan buat example. So this is our example. A wire of nichrome, a nickel chromium iron alloy. Alloy ni maksudnya combination of metals. Commonly used in heating elements is 1 meter long. So your L is 1 and 1 millimeter squared in cross-sectional area. So that's an area. So that is A over A equals to 1 millimeter squared, or 1 divided by 1000. This is for converting millimeter to meter. So you need to square this. Wait, I need to do this properly. Nanti kan korang confused. Okay, so 1 millimeter squared times with 1000. 1000. I want to get rid of millimeter and I want in meter. So 1 meter is 1000 millimeter. And this guy is squared, so I need to do this twice. 1000 millimeter. Okay, so this guy becomes 1 over 1000 over 1000. Okay, hope I'm right. So 1 over 1000, 1 over 1000 equals to 1 times 10 to the minus 6 meter. Okay, so that's your area squared. It carries a current of 4 ampere. Okay, 4 ampere. So L is 1, A is this, I is 4 ampere. It carries a current of 4 when a 2 volt potential difference, so this is your battery V, is applied between its ends. Calculate the resistivity of chrome. So let's try to visualize how this thing is. So this guy is 1 times 10 to the minus 6 meters squared. Let's try to visualize what's going on here. Okay, so a wire, we have a wire. So typically heating element macam mana? Saya tak ingat lah, lupa heating element. Dah lama tak buat EE. Tanggap ni lah heating element. So this is heating element 1 meter long and ada cross-sectional area. And then there is current flowing through when the battery is 2 volt. 2 volt, and then current flowing is 4 ampere. So this is the situation that we have. So it's asking, hey, what is the rho for this heating element? And we know that R, from this circuit, we know that we will have R, resistance, because based on V equals to IR. So I am going to solve for R first. So I know V is 2, I is 4, so I'm going to solve for R. R is 2 divided by 4 is 0.5 ohms. And I know that resistivity, this is resistance. Resistance is capital R. So I want to know what is resistivity, and the equation for that is R, capital R, rho L over A. So not only does it depend on the resistivity, it also depends on the structure of the heating element. So heating element tu kalau lagi panjang, lagi tinggi resistance. Kalau lagi tebal, lagi kurang resistance. So the design of your component also plays a part in determining your resistivity or your resistance. So you have your R 0.5. You don't know what your rho is because it is a combination of metals. So this is why you need to calculate for it. So your L is 1 and your area is 1 times 10 to the minus 6. Okay, so just use your calculator. So you will get rho as 5 times 10 to the minus 7, and your rho is the what do you call this? The units is ohm over meter. So we did not discuss about this yet. Okay, so how do I discuss this one? So let's see the table again. Okay, so this resistivity is ohm meter. Why is it ohm over meter tadi? Conductivity is 1 over ohm meter. Okay, betul. Kenapa 1 over... Why is it ohm over meter? Sekejap. This is meter. This is ohm. This is meter squared. So meter cancels out with meter. Rho should be ohm meter. So this is wrong. It should be ohm meter. Okay, so let me repeat myself about that. Let me use pink now. So R is equal to rho over L over A. Rho times L over A. So L is in meter, area is in meter squared, R is in ohms. So if I rearrange this equation, so I will get RA over L equals to rho. So R is ohm, A is meter squared, and L is meter. So this cancels out. So rho is ohm meter. Okay. So if you don't remember what the unit is, just go over this equation, this basic equation, so you will get it. You will get the answer. Okay, moving on. In an experiment, a square aluminum bar. Sorry, panjang ni soalan dia. Okay, so in an experiment, a square aluminum bar of 10.5 meter long and 1.5 millimeter width is connected to a 1.5 battery at room temperature. Okay, let's write down the information. So battery is 1.5 volt. Alamak, I have to take this call. Sorry. Okay, I'm back. Sorry. Banyak pula halangan hari ni. So in an experiment, a square aluminum bar of 10.5 meter long. Okay, so your L is 10.5. Yeah, I think I want to ask you guys to do it lah. Because saya dah kekeringan tekak. Okay, can I ask, let's see the list. Okay, sebabkan saya dah kacau Nurhan tadi, so Nurhan is off the list. Let's ask, siapa yang saya panggil lah? Yan E, saya jarang sangat panggil. Yan E. Yan E will be doing A. Okay, E and E will be doing A. It's okay if we get it wrong. We are here to learn. Okay, so don't worry about that. And then yang saya jarang panggil is also Nut Mango selalu. Afika, saya jarang panggil. So Afika will be doing B. Zahilda baru panggil ke tak so far? Anis Nadira will be doing C. Is that okay? Boleh eh? So, where's this? Afika is the second one. Buat hal lah. Afika. The first one was Yen, E. Third one is Anis Nadira. Okay, so I'm going to give you guys 10 minutes to do this question. Nanti kita akan discuss, okay? 10 minutes is long. Minutes is 10:44. 11:44. Hello, are you guys ready? Is Yen E, Afika, and Anis ready? No response. Is Yen E there?
Doctor.
Yeah. Okay tak? Dah siap tak A?
Dah.
Okay, sekejap Let me buat slide ni dulu sikit. So Yen E's question. Okay. Oops, lagi jawapan pula. Draw eraser. Saya tak cukup tempat lah. New slide. Okay. Okay, Yen E, what do you have for A?
I use the equation R equals to rho L over A.
Rho L over A, okay.
And then the L is 10.5.
L is 10.5 meter, okay.
Area is 2.25 times 10 to the power of negative 6.
Apa? A is?
2.25 times 10 to the power.
Times 10 to the power of negative 6, okay. All right.
And then
How did you get the
is,
area?
1.5 millimeter square.
1.5 millimeters. Oh, you squared that whole thing. Okay. So this so Yen E got this from the width, right? And it is a square. So square has equal sides. So Yen E is just multiplied this by, squared the whole thing. Okay. So rho is, let me write it here. 2.82 this value. Okay. 2.82 times 10 to the minus 8 ohms meter. This guy is in meter. This guy is in meter squared. Right? Meter squared. Yep. Okay, so this cancels out with the meter. So what did you get for the resistance?
0.1316.
0.1316 ohms. Okay. So is that what everyone got? Did you use this equation?
Yes.
Okay, Haikal dapat. All right.
Doctor,
Yep.
I have questions.
Mm-hmm.
For the area, we need to take which part of the area?
For the area, we need to take which part of the area? Maksudnya kat sini, this is a square aluminum bar. Kan? Bar ni panjang kan? So this is your aluminum bar and dia cakap it's a square. Oh, dia tak cakap square cross section Tapi saya ambil.
So which means at the left or at the long and mid? Which
At
one?
the left or at the end. Okay, so since kita tahu bar ni selalunya panjang. So what I had in mind was it looks like this. Alamak, tak kerti lukis pula. Macam tu. This is what I had in mind. Umar rasa gambar ni macam mana patutnya?
Just like yours, doctor.
Oh,
But I don't know which area to calculate.
Oh, okay. So the area is always the cross section. Okay, so when we cut something, cross section. So the area is the square part over here. So that's why they mentioned the word square. Okay, so the length is here. This is your L. This is your A. Okay, and then it is macam tu je lah. Dia memang cross section. How do I say cross section tempat yang kita potong lah basically. Kalau kita ada benda yang panjang, kita potong, that is your cross section. So for example, there is a pipe that has a circle area, circle cross section. Circle face. When we potong, that is your cross section. So the cross section is actually the circle face lah, the circle area. Okay. So that is the cross section. Okay, so that was a good question because I did not elaborate that much on what is area and what is on length. So always the area is always the cross section. Okay, and then moving on to B. B is Afika, the resistance of the bar between its end after immersion. So what do you have for us, Afika?
Okay. So for the resistance of the immersion, I use the formula R equal to R naught dalam kurungan 1 plus alpha times to delta T.
Mm-hmm.
So R naught I use again is answer just now.
Mm-hmm.
0.1316 times to 1 plus alpha dia 3.9 times 0 plus the negative 3
Okay, this guy. So 3.9 times 10 to the minus 3 times 10
and
is 3. Okay.
delta T is 100 minus 27 because it's a boiling point.
Okay, so it says boiling point. So that's why you use 100.
Yeah,
Okay.
so I got the answer. Wait,
Okay.
doctor, because just now I used the wrong or not.
Okay, sure.
I made the same mistake with Omar just now.
Oh,
I
okay.
I got 0.169
0.169.
ohm.
9 ohm. Okay.
Yeah.
Okay. So that is because your T final is in boiling point, in boiling water, right? So minus the room temperature T initial. Okay. Sounds about right. It's right, I think. So C, thank you, Afika. So C is Anis Nadira. Is Anis there?
Assalamualaikum doktor. Ada.
Okay, salam.
Doktor saya try
Ah.
Okay, saya pakai V equal to IR.
Hmm.
Dekat soalan kan ada bagi voltage kan 1.5. Lepas tu bahagi dengan R yang dapat daripada B.
So 0.1.
0.169.
What is your
Kejap
R?
8.87. 8.87. Betul kalau salah.
Okay, thank you, Anis. Saya pun tak tahu jawapan dia, tak apa.
Okay.
Alright, thank you everyone. So let's see if we got it right. So we got, tadi kita dapat 0.1316 or 1.32 times 10. Kenapa lah nak buat macam ni? So this is 0.132 or 0.1316. Yay, we got it right. So good job, E. Next one, the answer is 0.17. What did we get? 0.169, which is 0.17. Yay. So betul. And then this equation Anis buat V equals to IR, so 1.5 divided by the answer from B. So we got 8.82. Saya pun tak sure. Mana yang dapat tadi? 8.87. 1.5 divided by 0.169. Yeah, 8.88. Yang ni dapat 8.82. That's weird. 1.5 divided by 0.17. Okay. So sebab kita ada perbezaan value kat sini, this is why the value for this guy is slightly different than ours. Ours is 8.87. This one is 8.82. It's okay. Okay. As long as you show the correct working steps, it's fine. Okay. Walaupun jawapan berbeza sikit. Alright, so good job everyone. I think you guys got it. The equation is easy. It's just a matter of knowing where to apply it. Okay, and remember when we are talking about materials, punya resistivity, the cross section is always when you try to cut that material, that is the cross section. Okay. Okay, so this is our next subtopic, the last one and the most exciting one. We have half an hour to go, so let's do our best. I don't think we will finish, but it's okay. So this is electric circuit analysis. This is the one that I'm looking forward to teaching you guys because the first and the second one was quite easy. So this one is calculate the equivalence resistance for resistors. Tadi we talked about equivalence capacitors and also capacitance kan? Yeah, we talked about equivalence capacitance for capacitors. This one is equivalence resistance. Sebenarnya equivalent nama dia equivalent resistance for resistors in series and parallel arrangements. Calculate the current and voltage for resistors in series and parallel, and then apply Kirchhoff's rule in a DC circuit. It's called Kirchhoff's rule. Yeah. All right, so resistors in series. We know this already, what it means to be in series. It means that current flowing through the resistors are the same current. So if I have I over here, then the I flowing through R1 is also the same I flowing through R2. This is what it means to be in series. However, in series, we know that the voltage must be different. It is the opposite case for the current. So current sama, voltage maksudnya tak sama. Kalau voltage sama, which is in parallel cases, the current is not the same. So they are opposite lah. Okay, so here, if the I is the same, we have voltage number 1 and voltage number 2. And I also told you that the total for these components, the total for these resistors should be equal to a voltage of the battery, assuming that they are the only components there. So because R1 and R2 will give you an equivalent resistance of R12, the voltage of R12 should be equal to the voltage of the battery. Let's say it's 5. So R12, the equivalent resistance for this circuit should be 5 volt, which means that the voltage will be divided between R1 and also R2. Okay, so here the current is the same. We know this already. We know this already as well. So the equivalent resistance of a series combination of resistors is the algebraic sum of the individual resistances. Previously, when we talked about capacitors for series, it was 1 over C equivalent 1 over C1 plus 1 over C2. This is what for capacitors. For series in resistors, the R equivalent is simply R1 plus R2. So dia terbalik kat sini. Capacitors and resistors have opposite equations. Bukan opposite lah. Okay lah, opposite lah kot. So remember capacitors in series, equation dia macam ni. Tapi dia terbalik dengan resistors. Resistors simply tambah. And then for a parallel circuit, you know this already, I think you can predict. So C equivalent is equal to C1 plus C2. However, the R equivalent for parallel is like this. Okay, so remember 1 over, silap. So for parallel, we know that the C equivalent is equal to C1 plus C2, whereas for resistors is R, 1 over R equivalent equals to 1 over R1 plus 1 over R2. So this is senang je lah kan, sebab sama equation je macam capacitor cuma terbalik. Okay, it's pretty easy. Okay, so let's do a recap on resistors in parallel lah. So basically we know that in parallel the current is not the same because the voltage should be the same. They are connected by the same dots to the battery, which means that they are in parallel to the battery. So when they are in parallel to the battery, they will have the same voltage value. So if my battery is 10 volts, R2 will have 10 volts, R1 will have 10 volts. If the voltage is the same, the current should be different. The current should be a sum. So if there is I flowing through here, then the I flowing through this guy and this guy is the sum. Sorry, I1 and I2 equals to I. So I equals to I1 plus I2. Remember, we have water flowing. I see a junction, the water needs to split. So the split I1, they split into I1 and I2. However, I1 plus I2 should be equal to the sum, to the total, which is I. Okay, so you can't create or destroy the conservation of current, conservation of charges. So you can't have extra charge, you can't have less. So whatever goes in must come out. So here, the one that is going in is I, the one that is going out is I1 plus I2, which is equal to I. Okay. So the inverse, okay, we know this already. So So equivalent resistance. A complicated circuit, blah, blah, blah. Resistors in series carry the same current. Potential difference are not the same. Resistors act directly. Resistors in parallel, they have the same potential difference. Currents are not the same. So we have to add them by the reciprocal addition. Okay, this is just like recap, but like lagi serabut je daripada tadi. Okay, so let's do an example. Use the equation that we have learned so far. In the circuit shown, calculate the equivalent resistance. Okay, so and then the current in the equivalent resistance. So it wants to find out Req, the I in Req, the voltage across AB, this is the point. The current flow through the 20 ohm resistor. Wait, where is the 20 ohm resistor? It's over here. Okay, so if I were to look at this diagram and I wanted to find out what is the R equivalent, I typically like to redraw it, but you don't have to. So this is my 10 ohm. This guy is in parallel to the battery. I know I'm just like drawing the same thing, right? But sabar jap. And then we have 5 ohm and 20 ohm. Okay, 5 ohm and 20 ohm. This is 5 ohm. Oh, I'm missing something. I am missing one more. This is 10 and the bottom one is 5. Okay, when I redraw this, I can see that, okay, so this guy is in parallel with this guy, is in parallel with this guy, is in parallel with this guy. Am I like doing anything wrong to this circuit? No, sebab this point and this point is connected to this point. Okay, this guy kita tahu memang confirm parallel, these two branches, these two boxes. If I were to put the 5 ohm over here and the 20 ohm over here, it's basically the same circuit. I just redraw it to make it more obvious that they are in parallel. Okay. So you don't have to redraw. I just want to redraw so that you guys can see what I'm talking about. Okay, so this is 10 and this is 5 ohm. Okay, so 5 plus 20 resistors in series, you can just simply add them together. So this becomes 25 ohm. 25 is in parallel with 5, is in parallel with 10. So these three lines are in parallel. Okay, so 1 over R equivalent equals to 1 over 10 plus 1 over 5 plus 1 over 25. Okay, so I will get the R equivalent for here. Okay, 1 over 10 plus 1 over 5 plus 1 over 25. So I will get 50 over 17, which is 0.34 ohms. Okay, so what have I done so far? I combine these two because they are in series. If I have a current flowing called I, the current flowing through the 5 ohm is the same current that flows through 20 ohm. So I know that the 5 and the 20 is in series. And when I redraw this, I can see clearly that actually the 5 and 20, when we add them together, I can just write it as 25 over here. Okay, so this will become 25, and this 25 is in parallel with 5, is in parallel with 10. Is it in parallel with the 10 over here? No, it's not in parallel. Why? Because the A is connected here, but the B is not reaching the 10 ohm here. It's reaching a battery, so it's not in parallel. Okay, so that is why I am not adding it to this equation. So the answer is 0.35. Now let's redraw that. Okay, I hope everyone is still with me and not like dying slowly because this is tak susah lagi sebenarnya. So 0.34 ohms. Okay, pengacau dah sampai. What you want? What you want? Okay, so 10 ohm, 25 volt. So this is our equation now. This is our circuit now. 25 volt battery, 10 ohm, and the R equivalent that the R equivalent that I calculated just now, which is 0.34 ohm. Say hi to everyone. Hi.
Body tita.
Okay, stop bothering mommy, please. Okay, bye. So, and then we have current. Okay, remember current flows from positive to negative.
Careful.
Yeah, you be careful. Go over there. Don't be noisy. Okay, and then so my I flows from here. This is my I. Okay. So redrawing that circuit, I will get my battery, the R equivalent for the first part, and this is the 10 ohm. However, I'm not actually solving for A because the A is asking for, yes, thank you, close the door. Because A is asking for the equivalent resistance of the whole circuit. This is not the R equivalent for the whole circuit. It's only the R equivalent for this part, right? So I need to continue perjuangan saya ni. So my R equivalent for the whole circuit is actually 10 ohm in series with 0.34. So 10 plus 0.34 ohms. So that is 10.34 ohms. Toga CQ tadi 1/25 plus 1/5 plus 1/10. So 1 divided by answer. Macam lain pula. Sekejap 1/10 plus 1/5 plus 1/25. 1 divided by answer. Oh, silap. Jawapan dia 2.94. Suka hati je. Hey, why is no one correcting me? Are you guys sleeping? 2.94. Okay, because I'm paranoid now. Let me calculate that again. 1/5 plus 1/25. What did you guys get? 50/17. 2.94, yep.
0.94.
2.94, okay. So 2.94 ohms. Okay. So now in series, this becomes 12.94 lah. Okay, so that is our answer for A. So what did I do? I simplified the circuit first before calculating the equivalent resistance. How did I simplify it? I added these two guys together because they are in series, and then these in parallel, and then only this guy in series. Okay, so that is how we do the R equivalent. So the next one is the current in the equivalent resistor. So we have combined these. So now I can rewrite this. So I have a battery that is connected to an R equivalent, which is equal to 12.94 ohms. Let me not write this as R equivalent. This is our R equivalent. This is our R equivalent. Okay, so I have a battery of 25 volt, and there will be current flowing through the R equivalent. So based on V equals to IR, basic equation, so 25 divided by R is 12.94. So the current flowing through my R equivalent is simply 25 divided by 12.94, 1.93 ampere. Okay, don't forget your units. Units in ohm for resistor, and I current is ampere. Okay, and then it's asking for the voltage across AB. Before I proceed with C, let's see if I did it correctly. So we got 12.95, berkurang lah. Okay, so let's see how this schema jawapan buat macam mana. So here, they combined R1 with R2 to get RA. Yes, that is what we did. And then R3, R4, R5, RA. R3 is not combined as parallel, so 10, 5, and RA is in parallel. So you get RB, so parallel, only series and then parallel. And then RB is in series with R3, which is what we did. Okay, so it's the same. I don't think there's another way to do it. Ada ke? I don't think there is another way to do it. Unless you want to go for R4 and R5 first, to tambah R1 and R2, lepas tu baru macam, well, you can do it like that. Okay, so you can try other ways if you want to. But I don't think it's efficient lah. So V equals to IR. So 25 divided by our R equivalent gives us 1.93. And then the voltage across AB. So here they showed us VAB is across RB. Okay, what is RB? RB is our the one that we solved in parallel, which is 2.94. 2.94. Let me write that here. Okay, let me write it here. So we have our battery here. So we have our 10 ohm got, right? And this is the R that we solved in parallel, which is 2.94 ohm. This is our 10 ohm, and this is our 25. And let's see, where is AB again? AB is between here and here, which is here and here. Can, which means that this point is actually, if I solve this in parallel, it is between the R equivalent that I solved over here. Okay, so redrawing that, saya boleh REQ kat sini kan? Boleh juga. But if I want to be more precise, it should be over here lah. Sama je. Okay, so A is here, B is here. Okay, what did I do? This is not R equivalent. Sorry, this is can. Let me call it something else. RB lah ikut orang tu. Let's call it RB to avoid confusion. Okay, so RB, we have our 10 ohm over here. This is a resistor, not a scribble. And this is our RB. Remember, I solved for these 3 lines or the 3 branches, 10 ohm, 5 ohm, 25 ohm, and I got my RB. And I am solving in parallel between A and B point. So basically, if I get RB should be in between A and B. Okay, so this is where it is. Okay, so now it's asking, hey, what's the voltage at RB? Okay, what is the voltage at RB? And we know that 25 volts should be divided between these two guys, between 10 ohm and also to RB, which is 2.94 ohms. Okay. Since we already know what is the I flowing through RB, it is the same I flowing through the 10 ohm. Using our V equals to IR again, we can solve for our voltage at RB, which is simply VB equals to I, which is the same I flowing through the 10 ohm, which is the I equivalent basically, times with RB. RB is 2.94. I is 1.93. This is one, and it's okay, 1.93 times with 2.94. Okay, so I'm going to repeat myself. I want to know what is the voltage at resistor B. And I know what is the I flowing through here from here. This is the I. The same I flows through RB and also 10 ohm. And then we know that RB, the value is 2.94. So I can basically solve for V for this resistor. So VB equals to 1.93 times 2.94. So this will be equal to 5.68 volt. Okay. This answer is 12.94. This I is equal to 1.93 ampere. And then it's asking what is the current flow through the 20 ohm resistor. Okay, this is our resistor that we are looking for. Okay, let me just do it on a new slide. I want this diagram, please. Okay, so now it's asking, hey, what's the current through 20 ohms? Okay, and previously we talked about the circuit being simplified. Am I recording? Yes. Being simplified to be RB over here. This is 10, this is point A and point B. Okay, now if I expand this RB, it would look like this. Okay, you don't have to expand it, but this is for the purpose of me teaching you guys. So 10 ohm, 5 ohm, and also 25 ohm. 5, 10, 10. These three guys are connected by the same point. Oops. By the same point. So this point is the same as this point. This point is the same as this point. Okay, it's the same, basically means the same point because they are in parallel. Okay. So how do I know what is the current flowing through the 25 ohm? Okay, so previously I know the I flowing through here. That is my I flowing through R equivalent, which was 1.93 ampere, right? So I know that through RB, I am flowing, the current flowing is 1.93. The current flowing through the 10 ohm is also 1.93. So if 1.93 flows from B to A, this is B and this is A. Okay, 1.93, which means that dia akan berpecah kepada these three guys over here. Okay. So that is hard to solve sebenarnya. It's kind of hard to solve. What other information do I have about this setup? I know that the V across RB is berapa tadi kita kira dah? V was 5.68, right? It was 5.68. So if the voltage across RB is 5.68 and 10, 5, 25 is actually parallel to RB, so they are also 5.68 volt, right? So I can say that the voltage through here is 5.68 volt. This is 5.68 volt. This is also 5.68 volt. Okay. The question is asking me what is the current flowing through the 20 ohm. So this 25 is composed of 5 and 20. Okay, 5 and 20. So I know that the current flowing through the 20 and the 5 should be the same because they are in series. So basically I can just say, okay, the current flowing through the 25. So V equals to IR. I know what VB is. VB is 5.68. I want to know what is the current flowing through this section. Okay, let's just call it I. So I times R, which is 25. Okay, so I am calculating for the I that is flowing through the R equivalent in that branch, in this branch. So I is equal to 5.68 divided by 25, which gives me 0.28 ampere. The I flowing through Anis ketiga. Okay, so the I flowing through the 25 ohm is 0.28, and we know that the same I flows through the 20 and also through the 5. So we can say that the current flowing through the 20 ohm is simply 0.28. So I'm right. Alamak, 0.23 pada. So kenapa 5.67? Kita dapat 5.68. I think that is where we have that difference. 5.68. Yes. So it's 5.68. Here they said it's 5.67. Okay. 5.68 divided by 25, 0.22. Okay, lebih kurang 0.23. Ke saya yang salah kira calculator? Kejap. 5.68 divided by 25 is 0.28. 0.23. Benda lah salah tulis ni. Sorry So it is my fault. It's 0.23. Okay. So that is the answer. So the current through this 20 ohm is 0.23 ampere. Are we done with this question? Yeah. Okay. Any questions about this one? It's a little bit complicated. But nanti kita akan buat lagi banyak example, so hopefully akan lebih faham lah. But overall, for this question, was it okay? Did you guys understand what we were doing?
Yes.
Faham eh? Everyone else, okay ke? Do
Yes,
I
Yes, miss.
Yes, doctor.
repeat any part of this? So far, everyone is okay? So I'm going to just see you guys tomorrow then. Tomorrow di kelas lagi, don't forget.
Okay, doctor.
Okay, so take care everyone. I will see you tomorrow at 10 a.m. Okay, don't forget to have your lunch and jaga SOP. Take care, bye-bye.
Thank you, doctor.
Thank you,
Thank you,
doctor.
doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Bye. Welcome.
Thank you, doctor.
Welcome.
Thank you, doctor.
Bye, Fatri.
Doctor, I forget to mention that Aisha is not here, is not in class today because her grandfather passed away last
Oh,
evening.
okay. Okay, noted. Thank you, Afika. Aisyah,
Doctor.
Aisyah Maya.
Aisyah Fatimah.
Aisha Fatimah.
Aisyah Fatimah.
Aisyah Fatimah.
Okay, thank you.
Doktor, ada yang tanya, test nanti masuk dari chapter 15 sampai chapter berapa?
Chapter 18.
Oh, chapter sekarang.
This is the last one.
Alright. Thank you, doktor.
Bye-bye.
Bye-bye, doktor.
Thank you, doctor.
Welcome, bye.
Thank you, doctor.
Welcome, bye Ridho.
Doktor, nak tanya kejap yang soalan D tadi tu kan?
D last day tu.
Last kali tu. Kan R dia ambil 25 kan? Jadi kita ambil 20 je. Sebab dia kan nak yang dekat 20 je.
Okay, sebab kita nak kira the I flowing through the whole branch. So, sebabkan dia orang in series kan, so the I that is flowing through the 20 and the 5 is the same. And untuk dapatkan that I, dia kena pakai R equivalent untuk line tu. So memang macam tu.
Dia sebab kita guna V kan, V dia berasingan.
Dia is for that
V
whole
total.
line. Betul. Rumah is correct. So the V for that whole line is 5.68. So maksudnya saya kena pakai the whole R. Saya akan repeat balik pasal tu. Thank you Umar for reminding me.
Thank you, doctor. Bye-bye.
Bye.